So let's start the session. This is week 11 online live session for the NPTEL course on urban, urban utilities planning, water supply, sanitation and drainage. The course instructor is Dr. Devapratim Pandit. He is a professor in the Department of Architecture and Regional Planning at IIT Kharagpur. I am the teaching assistant for this course. I am Vaibhav Kabadwal. I am a research scholar in the Department of Civil Engineering at IIT Madras. So this week we will study about sewage treatment and natural and artificial treatment. In artificial treatment, what are the primary and secondary treatment? We will solve some MCQs, fill in the blanks and measure the following. So let's proceed. So in sewage treatment, let's understand what is sewage first. So sewage is the waste from kitchen, bathing, laundry, urine and night soil in dissolved, colloidal or suspended state. What all waste which we are producing from kitchen, bathing, laundry, urine and night soil, that in both dissolved and colloidal or suspended state, that is called sewage, and this is the main constituent of sewage. From cooking, salts will come, sweat from bathing and laundry and urine. This these are also the part of sewage, and pathogen from night soil is also a constituent of sewage. So this is about sewage. So we are going to understand how to treat sewage in this lecture. The dash is the discharge point of treated or untreated sewage. So even after treatment or without treatment, the point is called outfall point. The outfall is the discharge point of treated or untreated sewage. So from where in the last lecture we studied, this is the drainage, or that outfall sewer is discharging the water into a river. This is a river. If you see it in plan, this is a river which is flowing like this, and this is the outfall. What is the major fraction of total nitrogen in domestic sewage? What is the major fraction of total nitrogen in the domestic sewage? This is ammonia. Next. Factors which affect raw sewage characteristics. So from household, let's take the example of household. So how sewage is getting generated? So first we are getting the water supply. After getting the supply, we are producing sewage or wastewater. So whatever is the supply, on an average the sewage or wastewater will be generated. In general, we take it as 80%. So it depends on the level of water supply. The characteristic depends on the level of water supply. If it is water supply is like we can say the water is potable or water can be used, then more wastewater can be generated, and it depends on the lifestyle of the people residing in the community. So life, it depends on the lifestyle, it depends on the level of water supply and how much person people living in a home that decides uh, sorry. So it depends on the per capita pollution load. So how much per person is producing, like it is taken as generally 180 gram per capita per day fecal solids. So uh, it depends on how much waste is being generated by per person and settlement and decomposition in the sewer. So from that these households, sewers are laid. So how much is the settlement in the sewers and manholes, that also decides the uh, suppose let's take the example, this is the home, and from home the this is STP, sewage treatment plant. So the characteristics, these characteristics are measured here. That's why all those factors are coming into account. So how much travel time is there, how much settlement in the sewers, that will decide the raw sewage characteristics at the outlet, or that we call it outfall. So at outfall, uh, all these factors will be taken into account. Oxygen is supplied for aerobic process using the pump is called. So uh, in aerobic process, what happens, the organic matter, or specifically I can write it as biodegradable organic matter, is utilized, or I can say oxidized by microorganism if in presence of oxygen. In presence of oxygen, it is called aerobic process. And the process of supplying supply air or oxygen, specifically we need oxygen, it is called aeration. So this is about aerobic process. So we can say like organic matter plus oxygen is getting oxidized to CO2 plus H2O plus biomass. The organic matter means biodegradable organic matter. This organic matter is getting oxidized. This is oxidation. Organic matter is getting oxidized. It is called oxidation. And the oxygen is getting reduced to H2O. So this is called reduction. And the organic matter is getting oxidized. So organic matter is electron donor, and Oxygen here is electron acceptor. And this work is being done by so this oxygen is required by the microbe, and the microbe will consume biodegradable organic matter. So that's why it is producing biomass. This organic matter is getting converted into biomass because microorganism will consume this biodegradable organic matter, and they will uh, multiply or grow, and they will produce biomass. This is the concept. And this process of conversion of organic matter to biomass and gas. This is called biological process. This process is called biological process. And this is aerobic process. If the same process occurs in absence of molecular oxygen, then it is called anaerobic process. Activated sludge process is so the activated sludge process is a biological process. It's a biological process which is suspended growth system, suspended growth system, suspended growth aerobic process. So this is activated sludge process is a secondary treatment process. What are the zones of self-purification? So what happens? Let's take a simple example, which is as now understood. So this is a river. So there is a sewage which is being discharged into the river. This is the sewage. Sewage is being discharged into the river, and the sewer will mix with the river water, and the sewage will mix with river water, and this sewage consists of organic matter, and mostly it is biodegradable organic matter. And sewage itself consists of microorganisms or bacteria, so it contains microorganisms also. Microorganisms. Microorganisms will consume biodegradable organic matter, and they will consume river rivers dissolved oxygen. They will consume rivers dissolved oxygen. what is happening? The sewage consists of microorganisms and biodegradable organic matter. So the microorganism will degrade, oxidize organic matter, and in that process, microorganisms utilize oxygen, and that oxygen is taken up by the river. So the oxygen level in the river goes down. So if the oxygen level in the river goes down, aquatic life aquatic life is affected. Aquatic life affects because fish need at least 4 milligrams per liter of dissolved oxygen in the water to survive for fish. Fish need at least 4 milligrams per liter oxygen, dissolved oxygen in the water to survive. So if the aquatic life affects, the food chain also gets affected. So, okay, let's understand what is the self-purification process. So, there are 4 zones of self-purification. 4 zones undergoing self-purification process. So first, the clear water zone where there is no discharge of sewage. Uh, when we discharge the sewage, let's take an example that we are discharging sewage. So the degradation happens, then active decomposition happens, and then recovery. Zone of recovery means the recovery of oxygen. The oxygen is getting recovered, and then zone of clear water. So in the first section, we are getting this is the DO level. This is the DO level. DO level during the zone of degradation, the DO level is getting decreased, and then in the active decomposition zone, it reaches the minimum DO level, and then the zone then after a certain distance, you can see it like this. So this is the river water body. Here we are discharging. After discharging, the DO level will come down and then it will increase. So why it is going down and why it is coming up? The thing is, this is the DO, this is with length or time. And some books you may find it like after mixing this may take some time. There is some lag here because the water from back will come and this curve will start after some time like this. So in this case, during this interval, it is the maximum organic matter is being decomposed, and then only little organic matter is left. So reaeration is also happening. Because of reaeration, this DO level is increasing. So with length and time, dissolve oxygen in river. We will learn about this curve in the later slides. So the DO level goes down and then goes up. So in the zone of recovery, it crosses the 40% of the saturated water, 40% of the saturation DO level. So let's say that 10 milligram is the saturation DO level. Approximately, it varies from 8.5 to 9 from Indian context. So let's take 10. So if it crosses 4 milligram per liter, then we can say it is a zone of recovery. Let's understand this. So in the degradation zone near the outfall, so this is the outfall. So this zone is zone of degradation. Near the outfall of sewage, water is turbid with dark color and anaerobic decomposition of solid matter prevail. And in the active decomposition, so in the if you see physically, so the zone of degradation is sludge present, color getting turbid. So color is more turbid in the zone of active decomposition. So we can see grayish color can be seen, and the gases will start to evolve because in the active decomposition zone, the DO level is very less. So anaerobic decomposition will occur, and that will produce methane gas and CO2 and H2S gas. So CH4 and H2S are the gases produced from the anaerobic digestion. Because the dissolved oxygen content is less, so anaerobic digestion occurs, and the color of the water is grayish color in this zone. And in the zone of recovery, it is turbid and bottom sludge. So there will be sludge. So how sludge is forming? The organic matter is getting uh, converted to either biomass, or it is getting settled in the river bed. That's why this sludge is forming. So in the active decomposition zone, the water is grayish with odors. The odors are produced due to hydrogen sulfide, and scum may also be seen to the surface. And in the recovery zone, stabilization of organic matter takes place. BOD is reduced, dissolved oxygen more than 40% of the saturated, more than 40% of saturated value. So in the zone of recovery, the back the so in the zone of recovery, the main criteria to decide is it crosses 40% of the saturated value. That's it. And in the zone of in the clean water zone, the stream attains normal condition. So the clean water, so the stream attains normal condition, means whatever it was earlier, same thing happens. So same thing, same color. If it attains the same thing, same quality, then we say it is zone of clear water. This was about self-purification process. So in self-purification, the degradation is going on in the river water body naturally, self. So that's why it is called self-purification process. When sewage is used for growing crops is called when sewage is used for growing crops, that is called sewage farming. Simple. Sewage farming. When soil pores continuously decrease, when soil pores continuously decrease and soil gets clogged by deposition of solids is called sewage sickness. So now we will understand about the artificial methods of sewage treatment. So this is the artificial method. So like we understood how sewage is getting produced. So let's understand one more time, very short. So from city, let's take the example. This is the city. So from elevated water, let's take the example of elevated water tank. So this is elevated water tank. I'm being here more specific. Elevated water supply tank. The water is getting supplied through pipes. Water pipes or pipelines, and then city is producing, this is water, the city is producing wastewater. Sewage, and that sewage will be carried out with the help of sewers, manholes, pumping stations, and from those pumping stations, and after passing through all this, it will go to sewage treatment plant. That is artificial method of treatment. Artificial method of sewage treatment. And here if you can see, this is tank. Here if you can see, this is water treatment plant. So from water treatment plant, the water is being supplied to elevated reservoir, elevated water supply tank, and then through pipes it is going. So this is the whole scenario. So here let's take, this is the example of, this is the river. So from this river they are taking the water through intakes, treating it, and then from sewage treatment plant they are discharging it. This is called outfall sewer. This is the analogy. So let's understand now the artificial method of sewage treatment. So let's us understand this flow chart, and then we can proceed. So the raw sewage is, so here we have raw sewage. Here we are getting the raw sewage. The raw sewage in the sewage treatment plant is first passed through screens. The screens will remove the floating materials like bottles, cloth, any other material. So the screens, after screens, the inorganic particles which have the density of around 2.4 to 2.6, specific gravity of 2.4 to 2.6, that will be removed in the grid chamber. The detention time provided for grid chamber is 1 to 2 minutes. So grid chamber is nothing but a kind of sedimentation tank. So after this grid removal, so screens will remove inorganic, organic floating material. Grid will remove inorganic suspended solids. Now the leftover suspended solids which were lighter or which are lighter, they will be settled in the PST. So the PST will remove mostly organic suspended solids. PST, primary settling tank or primary sedimentation tank, will remove the light suspended solids which were not removed in the grid chamber. So here we require 2 to 4 hours of settling time for settling the organic solids. So by this time we have removed most of the suspended solids, whether they are organic or inorganic. So in primary treatment we have removed suspended solids. See, screen will remove suspended or floating solids, inorganic suspended solids, organic suspended solids. So it doesn't mean that the PST can't remove inorganic solids. If we remove the grid chamber, PST can remove all the grid sand particles, which can means if we remove the grid chamber, all the solids can remove in PST. So, but why are we separating it? Because the in the grid chamber, the inorganic solids cannot be degraded biologically. So we want these solids to further degrade biologically. That's why we are providing separate grid chamber and primary settling tank. So after this, till this extent, we have removed suspended solids, and then we in the sewage we have majorly organic solids are present. So the organic solids which are in dissolved and colloidal form, that can be removed or oxidized using biological processes. So that's why we provide biological reactors for removal of biodegradable organic matter. And after this, in this biological reactor, what happens? Biological reactor. What is happening? The biodegradable organic matter is getting converted to biomass. So that is this is in dissolved form, and this biomass is in suspended form. So the advantage is the pollutant, let's say this is the pollutant was in dissolved form, is now converted to the suspended form, which can be settled in the secondary settling tank or secondary sedimentation tank. So these are the secondary solids, primary solids which are already present, secondary solids which are present in the biological treatment that are removed in the secondary settling tank, and the effluent is further treated. The effluent is called treated sewage, and that can further go for the tertiary treatment where we can remove nutrients, or we can go for further polishing of the treated sewage. So now what is happening here? So the PST and SST both will produce sludge. So these both sludge, the sludge has the capability to hold the moisture content. So the sludge is then mixed and passed through a thickener. The thickener will remove the water out of the from the sludge, and the water which is removed is again sent back to the PST, because the water will contain dissolved, or it may contain some suspended organic matter. So it will contain both suspended and dissolved organic matter. So that's why it is passed through PST. In PST, if the supernatant, if it passes through the PST, the settlement, the suspended solids will settle, and the organic, the dissolved organic matter will pass through this biological reactor. That's why the supernatant is passed through the PST further, and then the thickened sludge is digested anaerobically. The sludge, after removing the water through thickener, is sent to the anaerobic digester. From there also, what is happening? The sludge is getting stabilized in presence of microorganisms. So this is a biological process. So in the anaerobic digester, the sludge is getting digested, and during the process of digestion, the sludge is converted to solids, liquids, and gases. So the liquids are again called supernatant, which will go at the top, and the gases, we can get the useful gases. This is CH4. So from anaerobic digestion, we can get methane gas, which has a good calorific value, and that can be used as a fuel. So the and then the digested sludge, the solid which is produced, which is the from the sludge, the solids which are getting produced, that is called digested sludge, and that is then further handled, like we can send it to the sludge drying beds, and then it can be disposed of in the fertilizers for agriculture purpose. So for sludge handling means like it can be sent to the drying beds. These are called sludge drying beds. So after that, it can be put over the agricultural fields because it contains nutrients. So this was about aerobic process. So if you are using aerobic process, then this flow chart is used. is for aerobic process. So let's see what happens in the anaerobic process. So in the conventional anaerobic sewage treatment, we don't need uh, primary sedimentation tank. So you can see after the raw waste, after this grit chamber, because why are we removing grit? Because grit is inert in terms of uh, biological activity. So the grits mean sand, some heavy particles, heavy inorganic particles are removed in the grit chamber, and in this anaerobic reduction and synthesis, this process, both suspended and dissolved organic matter is degraded in the anaerobic reactors. And after this anaerobic process, we provide settling. So in this settling, the biomass will be settled, and then it is again sent for the post treatment, that can be tertiary treatment or it can be polishing. So this process can be anaerobic filter, and it can be anaerobic RBC. RBC is rotating biological contractor. Fluid bed SMAR is fluid bed sludge management and anaerobic reactor. UASBR is upflow anaerobic sludge blanket reactor. So these are the conventional uh, anaerobic sewage treatment method. So what is the purpose of sludge recycling of sludge in ASP? So ASP, so in this flowchart, ASP is activated sludge process, which is an aerobic suspended growth system. So here we will put the ASP. So from PST, this is sludge, this is effluent. From PST, this is PST, this is PST. This effluent is sent to the aeration tank. This is aeration tank. And then from in this aeration tank, what happens? The microbes will utilize the organic matter, dissolved organic matter, and they will oxidize the biodegradable organic matter into CO2. And when sewage comes in contact with microbes, the microbes will eat the sewage, or specifically if I say organic matter, and they will grow or they will multiply. And after this aeration, in the aeration tank, we provide mixing and we provide aeration. Mixing, and then we provide aeration also. Because this is aerobic suspended growth process, and after this the biomass which is formed in the aeration tank is settled here. So effluent is then further passed for the subsequent processes. So this sludge is recycled back again to this aeration tank. So that this is done, why? Think this is done to maintain the biomass concentration in this tank. So the answer is to maintain the active biomass concentration in the aeration tank. That's why. So purpose of wastewater recycling, here it is, wastewater recycling. In the trickling filter. So here in the previous slide you can see only the settled sludge, the recycling is for sludge. not for the effluent. In the trickling filter, EST, trickling filter, so the effluent is recycled back. Sorry. Let's understand what is the trickling filter. The trickling filter, this is a filter which is made up of media, very fine particles. So the water passes through this uh, bed. Wastewater trickles through this. Wastewater trickles through this trickling filter bed, as we can say, it trickles down, and in the media itself, a layer of biomass forms. So this is the media of trickling filter, and the layer of biomass. The layer of biomass will form. The layer of biomass will form. The layer of biomass will grow over the filter media. As the wastewater trickles through the filter media, this layer grows, and after growing, what happens? At a certain time or instant comes when this layer becomes anaerobic, because they are oxygen cannot reach there, and the outer layers are aerobic. First, understand this layer is called slime layer. Slime layer. The the layer which grows, the biomass layer which grows over the surface of media is called slime layer, and this forms uh, this form this layer consists of microbes, and these microbes rely on the uh, organic matter which are present in the sewage, and so the same thing happening, and the wastewater contains dissolved biodegradable organic matter, and they are consuming the biodegradable organic matter, and this layer is growing. A certain time or instant comes when this anaerobic region forms, and there is one anaerobic. There are two different regions, anaerobic and aerobic. These anaerobic bacteria will not get oxygen and food. Food means organic matter. They won't get food, and they try to eat themselves, and then in that case this layer gets sloughed off. That is when the removal of this slime layer is called sloughing. So how can I write it? So over this filter media, first slime layer forms. Slime layer formation over media, then slime layer, and then due to the growth, one is anaerobic, one is aerobic. So because the anaerobic layer cannot get oxygen and food, it gets removed from the uh, it removes it detaches from the media. That process is called, then it detaches from the media, and that process is called sloughing. sloughing. So slime layer and sloughing, these are the two terms. So the sloughing depends on the hydraulic loading rate, or simply I will say more flow, more sloughing. So if like suppose there are particles, and if more layer will form, it will clog. They will clog the filter. So to reduce the clogging and to uh, pass the water continuously, we will what we will do, we will just supply we will wait, I will make one more diagram. So this is PST. So from PST, water is sent to the trickling filter. After trickling filter, the water, yeah. So this after the sloughing, the biomass will come at the outlet and then will provide SST. So this biomass is then uh, settled in the SST. From SST, this effluent water, sludge is taken somewhere. This effluent is transferred to the trickling filter to provide more hydraulic loading. To provide more hydraulic loading means more discharge. So because of this more hydraulic loading, sloughing may occur early or easily. That's why we are recirculating the effluent wastewater. So this is the purpose of recycling, wastewater recycling the trickling filter, which is sloughing. Sloughing of slime layer. That's it. What is the next? For sedimentation, for sedimentation tank, specific gravity of suspended solid is. So it is talking about, for grid chamber it is 2.4 to 2.6. For PST and SST, for PST and SST it is around 1.1 to 1.02. Because organic solids are lighter solids. Organic solids are lighter. Dose of coagulant depends on kind of coagulant which we are using. So and amount of suspended impurities. What is the concentration of suspended impurity, strength of sewage, pH of the sewage, because coagulant dose sometimes require alkalinity. So it depends on the pH of the sewage, temperature of the sewage, mixing and flocculation time, degree of treatment desired, how much treatment we desire or we require. That so the coagulant dose depends on these factors. Gas treatment of sewage include the process of screening, grit removal, and removal of suspended solids by settling and colloidal solids by settling after coagulation using chemicals. This is primary treatment. We studied in the flow chart. What are waste stabilization ponds? Waste stabilization ponds. So these are the artificial open flow through earthen basin designed to treat sewage. So these are the open flows on the earth which are designed to treat sewage. How facultative pond works. So let's see it here. So this is how the facultative pond work. So the sewage is discharged here and some part will settle at the bottom. Okay, and then oxygen can come inside because of the uh, concentration gradient. So if there is some deficiency of oxygen in this water, oxygen will come from outside, and CO2 if produced excess, it will go outside. And other gases also will go and come that way. So during the sunlight, the algae will consume the uh, CO2, ammonia, phosphate, which is produced by the bacteria, and it will produce new cells and it will give oxygen. So during the sunlight, during the daytime, the algae will consume the products which is produced by bacteria. These can be ammonia, carbon, phosphate, and it will grow. This algae will grow and produce oxygen, and this oxygen will be utilized. This oxygen is utilized by bacteria, and these bacteria can be facultative and they can be uh, yeah, these bacteria can be facultative and they can be the bacteria which are present here, they can be strict anaerobes, and the bacteria on the surface they can be strict aerobes. So these bacteria will further utilize oxygen and they will utilize this organic this sewage, and they will produce CO2, ammonia, and phosphate, and in that way the treatment happens. And the relationship between algae and bacteria is called symbiotic relationship. uh, yeah, so the effluent will contain algal and bacterial cells, and in the, if you see, this is the aerobic process, and in the bottom the anaerobic process goes on. The organics, so in the anaerobic process, organic alcohols and acids are produced, and further methanogens will convert these organic acids into methane and CO2 and ammonia, and this further will be taken up by the algae, and the algae will convert it in presence of sunlight. It will grow and it will produce oxygen that is further utilized by the bacteria. These are aerobic bacteria. And this bacteria, again we discussed this raw sewage, it will treat the raw sewage and convert it into CO2 and S3 and PO4. So this is about aerobic and anaerobic process in the facultative pond. So in the facultative pond, the name facultative means it can act as both activity, aerobic and anaerobic activity, uh, both go simultaneously. So algae bacteria symbiosis happens in which of the following oxidation process? This is facultative pond. The process of removing oil and grease from sewage is called skimming. So what happens in a skimming tank? The oil and grease are lighter. Oil and grease are lighter. They have less density than water. Less density than water. So they will float on the surface and they can be skimmed off. They can be skimmed. These are oil and grease. So skimming tanks are provided for these things. In trickling filter of attached growth system, as sewage moves through the filter media, a biological dust is formed which absorbs the organic material in sewage. That is called slime. Biological slime is formed which absorbs organic material in the sewage that we discussed. How SBR works? So SBR is sequential batch reactor. So in the activity sludge process, we understood it like we have one sedimentation tank, we have before that one aeration tank, and then two tanks are required. But in sequential batch reactor, SBI is a variation of activated sludge process which combine all the treatment steps and processes into single basin, thus reducing the area requirement. So this requires automation. Like there is only one tank, so the one tank is first filled for some time, so that is called filling time, and after it is filled, then some time is provided to react. So in the reaction phase, what is happening? The same process which is happening in the aeration tank, the organic matter is getting eaten up or oxidized by the organic matter, and the organic matter will be converted to biomass. In that process, some part will be oxidized to CO2 and it will form biomass that in the reaction phase. And after then the reaction phase is in the reaction phase mixing and aeration is provided, and then it is allowed to settle. So we will stop the mixing, we will stop the aerators, and then it is allowed to settle, because the microbes which which were the microbes which were produced due to this reaction phase will settle at the bottom, and then after the settling phase we will decant, we will remove the top, the water from top, and uh, that treated water is further sent for the next treatment processes. So during the decanting also the mixing and aeration is stopped, that's why it is minus, and plus minus means mixing and aeration can or cannot be provided, that's why during and during the decanting the effluent is the treated wastewater is removed, and in the idle phase the waste sludge, if this excess sludge develops, it can be removed, and then the waste and this then again we can fill it for the next cycle. So this is the sequential batch reactor. So sequentially, because batch means once we are putting and then we are allowing it to do the process, so there is no continuous inflow and outflow, so that's why it is called batch. In a batch we are doing the treatment, so that's why it is called batch reactor. And sequence means sequentially we are doing first filling, reaction time is provided, then settlement time is provided, then we will providing time for decanting, the, then it is kept idle. So this is how a sequential batch reactor works. So this is a question for match of the following. So activated sludge process. So large porous bed with filter media facilitating aerobic bacteria growth. That is attached growth system. So R is P Q R is first. Flow through earthen basin. That is stabilization pond. Q is second. So P should be third. Let's see. Sewage containing organic matter is aerated in an aeration basin. Yeah. So P is third. So the answer will be 3, 2, 1. 3, 2, 1. The answer is A. Yeah, the answer is A. What is membrane bioreactor? So it is kind of similar to conventional activated sludge process. Let's see what is the change. So we have conventional activated sludge process here. So here we can see after this secondary sedimentation tank, which we call it SST. So in this secondary sedimentation tank, some part of sludge is wasted and some part of sludge is recirculated back. And the effluent, the thing is that all the biomass may not be settled in this secondary sedimentation tank. So when membranes evolved, we thought of putting the membranes. So let me tell you about the membrane. So you might have heard of RO plus UV. RO is a kind of membrane. So we have membranes like microfiltration, nanofiltration, and reverse osmosis. So these will utilize membranes. So the membranes are put inside and the effluent is pumped outside, and in that case we can get a thickened sludge inside this SST. So this is called membrane bioreactor. So in the biological process we have introduced membranes here. So in your homes you might have seen membranes. This looks like this cylinder. So in homes like Kent or any other Aquaguard, they are selling the small water treatment plant. So the membrane is kept inside and the water is taken out of that membrane. That has a very good effluent quality. So for that we don't need sand filtration and disinfection. So that membrane can remove the bacteria, viruses also. They are very small pore size. So when membranes are kept inside, so the effluent quality improves and the settlement of the sludge in the SST also improves. So but it requires more energy requirement. But the effluent is good quality. So this is the only difference in active to sludge process and membrane bioreactor. Rest all the processes are same. In the membrane bioreactor, the process of pumping permeate water back to the membrane is called membrane backwashing. So what happens? Let's take this as a membrane. So in membrane the pores are very small. These pores are very small. Pores are small. So let's take the examples. This is the membrane. So it has so many pores. These are pores. Let's take. The pores will clog with time if you use it for long periods. So membrane backwashing is required. So it can be done through air backwashing, anti-fouling chemicals, like this. So when water is pumped back, when water is pumped back, water is pumped, then it is called membrane backwashing. And it can be done through air or some chemicals or intermittently if we can use, then we can get less clogging. That is called membrane backwashing. Thank you. Thank you for the session. So this was the week 11 live session.